Okay, so we have this question here, and it says a stone is thrown vertically upwards and returns to the ground after 5 seconds. Find the initial velocity and the greatest height reached. So we have modeled out this question, and this is the exact pictorial representation of this question. The object is thrown vertically upwards and then it returns to the ground, and they said it goes up and comes down in 5 seconds. But imagine if you have, let's see another scenario here. Imagine if you have another object entirely now, and the object goes up and comes down in 8 seconds. In 8 seconds. So the object goes vertically upwards and returns to the ground in 8 seconds. What does it mean? It actually means that the object gets to the maximum height in 4 seconds and then comes down in another 4 seconds, giving you the total of the exact 8 seconds it spent in the air. So what does it mean? If the object spends a total of 8 seconds in the air, that means it goes up in 4 seconds and comes down in another 4 seconds. So we're actually dividing the total time in air by 2 to get the time it will take to get to the maximum height. So if it spends 8 seconds going up and coming down, it means if I now divide the 8 by 2, I'll get 4 seconds. So that means it spends 4 seconds going up and another 4 seconds coming down. Even if you even change your mind and say, okay, this time around it spends 10 seconds going up and coming down, then just divide the 10 by 2 to find out the time it will take to go up alone and come down alone. So if it spends 10 seconds in going up and coming down, then divide 10 by 2, you get 5. It then means that it spends 5 seconds going up and the remaining 5 seconds coming down to give a total of the whole 10 seconds. So that's the logic here. So in this question, they said here that the stone is thrown vertically upwards and returns to the ground after 5 seconds. It means it spends a whole 5 seconds going up and coming down. Then that is, if we want to get the time it spent in going up and getting to the greatest or maximum height, it means it spent 5 seconds divided by 2 to get the time it will take to get to the maximum or the greatest height. And what is 5 divided by 2? 2.5. It means it spent 2.5 seconds. Now, according to the question, it spent 2.5 seconds going up and another 2.5 seconds coming down. And if you add the 2.5 it spent going up and the 2.5 it spent coming down, it will sum up to 5 seconds. So now, and of course we know that if the object is going up, the velocity is reducing with time. That means the object will be experiencing retardation and your acceleration due to gravity will attract a negative sign, minus g. And when it's coming down, the velocity is increasing with time. That means your velocity, and that means that's acceleration for you, and your g will attract a plus sign. Remember, negative acceleration is actually retardation. So while the object is going up, the speed is reducing, the velocity is reducing with time. That's why the acceleration going up becomes negative, giving you a retardation. Retardation is the reduction of velocity with time. That's why the acceleration now attracts a negative sign to show you that it is actually retardation. Then while coming down, the velocity will be increasing with time. That's why we have a plus sign for the g here. So that's just the basics for the question here. So they now said find the initial velocity and the greatest height reached. And don't forget that at the greatest height here, your final velocity v will be 0. Don't forget that. Your final velocity will be 0 at the greatest height or at the maximum height, because it's going to pause a bit, then start another journey while coming down. So they're asking us the initial velocity with which the stone is used to be thrown upwards. So now let's look at the question carefully. Now let's look at the calculation. So what we have here, solution, we know that our v is 0, exactly what I said here. At maximum height, your final velocity is 0, and we know that our acceleration due to gravity, if we're looking at the object as it's going up, will be a negative 10. Since the value is 10 meters per second square, we're going to use minus 10 meters per second square because it is going up and it is experiencing retardation. So what else do we have? We have a time, but our time will now be half of this because we are considering the first journey, just the part where it's going up. That's what we want to consider, and the part where it's going up, you just spent only 2.5 out of the whole 5. Remember, it is spending only half of the total time in air, which is 2.5, and it's spending the remaining 2.5 in coming down. So we're going to say 5 seconds divided by 2 to give us 2.5 seconds. So that's our time. Then they want us to find our initial velocity, which is u. We're going to put a question mark. So definitely from what we have here, this is question 1. Remember, they also said we should find the greatest height reached. That will be question 2. So let's look at our equations of motion. But remember, we are going to consider the equation of motion for objects moving towards the earth or away from the earth. Objects moving towards the earth or moving away from the earth. And definitely we'll have v equals u plus gt, h equals ut plus half gt square, v square equals u square plus 2gh. And of course, we know our g here stands for the acceleration due to gravity, and even if it's retardation, we'll still replace the g with the value minus 10 if it's retardation. And of course, this time around it is retardation. So which of this formula blends with our parameters here? So let's see. So we have vgtu. So which one is vgtu? This is vgtu. So definitely this is our game changer here. So this one will work perfectly since it blends with what we have here, vgtu, and we have vgtu. So, and we are asked to look for the u. So writing out the formula without wasting time, we will then have that since vg, this is the winner, we are using this one to solve. So write it, v equals u plus gt, and of course we know the v is 0, so we'll say 0 equals the u we are looking for, and of course we'll say plus open bracket minus 10 times this t, the g is minus 10. Of course, we know why we're using minus 10, because it's going up and it's experiencing retardation, times the t, which is 2.5 seconds. So we now say 0 equals u plus times minus, then 10 times 2.5 is 25. Then we now have, if you bring the u over to the left hand side, the plus sign in front of the u becomes minus. We now have minus u. Of course, we know 0 is nothing, so that one goes, equals remaining the minus 25, and we know minus cancels out minus. Then we now have u equals 25 meters per second for our initial velocity. Then for question 2, we will have, they say we should find the greatest height. So greatest height is h, and we're going to put a question mark. Of course, we still have our g, and the greatest height, it is getting to the greatest height, so it is still going up to that greatest height, and it means it is also experiencing retardation. So our g will still be minus 10 meters per second square since it's experiencing retardation while going up. What else do we have? Our time is still 2.5 because it is half of the total time we're still using since it's going up, 2.5 seconds. Then we now have our initial velocity now, and it's 25 meters per second. So let's see which formula blends in again from all the equations of motion. So let's see which one blends in this time around. Now we have hg, hg, we have hgtu. So we have HGTU. This one blends in. We have, oh, we forgot to add something. We also have V. The V is still 0 because they say we should find the velocity at the maximum at the greatest height, and at the greatest height our V is 0, so we still include that one, V equals 0. So we will then have, so we have many options. So we could actually use either this or this because it blends in. We have HGTUV, we have HVU, and it's still here too. HVUG still blends with this one, or for this one HUTG, HUTG. So any which way, but I would prefer we use this one to make our work very easy. So we have V squared. Now settling with this one here, so writing it out, we have V squared equals U squared plus 2GH. Remember the V is 0, so we have 0 squared equals 25 squared, which is for my U, then plus 2 times G, that's bracket minus 10. Remember it's still going up, that's, we are using only the upward direction this time around, then times the H we are looking for. So we now have 0 squared, which is still 0, equals 25 squared is 625. Of course, plus times minus is minus. 2 times 10 is 20 times H, we have 20H. Then the 0 leaves, 0 is nothing. The plus 625 moves over to the left to become minus 625. So we have minus 625 on the left hand side equals to, only the minus 20H will be on the right hand side. So divide both sides by minus 20. Dividing both sides by minus 20. So minus 20 cancels out, minus 20. Then 20 in 625 will give us 31.25 actually. So your H will now be equal to 31.25 meters. So very, very easy. So that's just it.